Hello and welcome to the Bealtaine Living Earth Festival and Living Earth TV. You're all very welcome to our presentation tonight. I hope it finds you well. Thanks for coming in. I'm just going to tell you a little bit about the festival and that before we get into meeting our guests who are going to be giving you a presentation this evening. So the Bealtaine Living Earth Festival, we're into our 17th year, and this is actually our second virtual festival, which has been amazingly rewarding and challenging. It has given us, we're missing out on meeting people, we're missing out on getting out into nature, which we would usually be doing at this time of the year. We'd be going on a walk now by the coast and taking in the beautiful scenery and wondering at our natural biodiversity, the luck that we have to live in such a wonderful part of the world with so many fantastic places around us and spaces around us. And of course, in the last year, we've all been focused into having a smaller space, and we've been discovering that even in that there's biodiversity, that it's everywhere. It's under your feet and even under some of our fingernails. So welcome along to Living Earth TV. We'd love to hear from you. We're on social media, on Facebook and Bealtaine Biodiversity, and you can tweet us and you can Instagram us, and you can on @calmastwit, and you can send your emails to calmast@wit.ie. So yeah, please do feel free to get in touch with the festival and send us your pictures, enter competitions, and indeed enjoy our presentations. This evening we're really lucky to be joined by a marine geoscientist who's Dr. Kieran Craven. And now Kieran is involved with the CHERISH project, which is running both here and in various other places. We'll hear about that a bit later. The CHERISH project is climate heritage, environment, reefs, islands and headlands, I believe, is the official longer version. And we're going to be talking as well briefly with Robbie Galvin, who's a geologist, and he's the project manager at the Copper Coast Geopark here in Waterford. We'll have a short question and answer with the guys afterwards. So you can, if you want to, during the presentation, you can type things into the chat and we'll ask afterwards. And also at the end, if you're willing to come on and unmute yourself, and you can become part of the chat. We try in the festival to sort of reproduce in as close as we can the some of the atmosphere of actually meeting up with people. So you're all very welcome, and I hope you enjoy it. We'll also have our competition winners later on. We have a short presentation from TY students here in St. Mary's in New Ross as well to enjoy. But for the moment, what I'm going to do, I'm going to hand you over to Kieran Craven now, and Kieran's going to hopefully explain a bit more about the CHERISH project and what they're doing. They're how they're helping us understand the issues that we're facing on the coastlines and the islands and that sort of thing. So it gives me great pleasure. I'll bring in, I think, Robbie first, actually, to tell us a little bit about the Copper Coast, the Geopark there in the Copper Coast. So, guys, welcome on, and it's great to have you. And thanks for coming on. And maybe you want to go ahead at your.
Sure. Yeah. Great. Thanks very much. Thanks so much for having us here tonight. It's great. Like you said, I'll just introduce myself and talk a little bit about the Copper Coast Geopark and what that is, what we do, and where it is. and then Kieran will kind of talk about the CHERISH project, who are working within the Copper Coast Geopark. So I'm just going to share my screen with you briefly, just for a few moments, if that's okay. Yeah, so it will be, as you said, ideal to be out on the Copper Coast somewhere, looking at the rocks and looking at the coast. It will be actually a beautiful evening tonight to do so, but hopefully just give you a brief sense of what it is. The Copper Coast is a UNESCO Global Geopark, which is an important designation from UNESCO, which is the United Nations Environmental, Social and Cultural Organization, maybe more familiar to many people as the designation, the World Heritage Site. The Geopark label is on the same program within UNESCO as the Heritage Site program. It's one of three similar designations: biospheres, geoparks, and heritage sites. But whereas the heritage site or UNESCO Heritage Site goes back to 1949, the Geopark designation is pretty new. Only since 2015 it's been properly ratified. There's 161 areas throughout the world that are designated just like the Copper Coast, part of a network of UNESCO Global Geoparks, which are areas that are recognized as having both two things. One is a particular, like a geological heritage, which is internationally significant as determined by the International Union of Geoscientists, but also an area that has a strategy to sustainably develop and harness that geoheritage for the benefit of the people who live there, and also not to the detriment of the heritage itself, because in many parts of the world, geological heritage and environmental heritage is often exploited and overused. You can see this in places where fossils are extracted and sold, and our minerals are mined and sold in inhumane and unsustainable fashions all throughout the planet. Geoparks are an attempt to try and bridge the gap between how we live and the planet we live on. Actually, two other areas within Ireland similar to the Copper Coast, which is, if you don't know the Copper Coast, it's an area of coastline between the towns of Dungarvan and Tramore in County Waterford. It's about 17 kilometers of coastline and goes inland about 5 kilometers. There's two other similar areas. One is the Burren, which many people are familiar with, and the other is, which is in County Clare, and the other is the Marble Arch Caves, which is an area designated between the counties of Fermanagh and Cavan, a cross-border area. And this, the Copper Coast Geopark, is so called because of its mining heritage, which goes back to the 19th century, where one of the largest copper mines in the British Empire once worked to take copper out of the rocks around Bulman, around the area around Bulman and Knockman, and then also because of the rock itself. I'm just going to have two very brief slides to tell you a little bit about geology, because I want to give the majority of this to Kieran, who will talk about more so the immediate and more future effects of what are geological processes in environmental processes in continuous operation. But the Copper Coast tells a story of Ireland 460 million years ago, back long before the dinosaurs evolved, and in a time when Ireland was actually split and a seam, which is known as the Iapetus suture, where two parts of Ireland, or Ireland's island, were thousands of kilometers away from each other in a completely different world, which was highly volcanic in this part of Ireland, where we have two volcanic centres, one in Bulman and one in Kilfarcy, that we could see. And if we were there on the coast tonight, we'd be looking at these rocks and we'd be talking about this exact thing. We'd be talking about the contacts between dark mud rocks and light felsic volcanic rocks, and the different kinds of magmas which formed the different kinds of cliff and shoreline environments that we have in the Copper Coast. However, the most continuous and or the most prevalent process currently shaping the coast is the action of the sea, which is far more recent and continuous to where we are now. So talking about the effects of the climate and the sea, and how what CHERISH is doing to study that, I think Kieran will kind of be great to continue on what I'm speaking kind of into the present day, and then we can come back to geology maybe at the end, because Kieran is also a very good geologist. So I'll hand over to Kieran now on that note.
Excellent. Thanks very much, Robbie, and thanks, Ben, for the introduction. I will now get my slides up. And thanks everyone for joining us as well. I know it's a beautiful day outside at the moment, so really appreciate taking the time out of your day to listen to some of the work that we're doing in Waterford, in the Copper Coast, and elsewhere. And I'll be giving a kind of like a showcase of the work that we're doing in CHERISH to try and address the issues of climate change to coastal sites around both Ireland and Wales. And Ben, thanks for giving the acronym. I've been working at this 3 years. I still have to check to remind myself of what CHERISH actually means. So no, so really appreciate that. I tinker with the title, and for this talk as well, I made a few changes, and I think the most important change that I made is right at the very end of my title. It's the question mark into it. And as we go through CHERISH, which is a 5-year, it's now 6th year, we got 1 year additional funding, so it's a 6-year EU funded program. It's really the question mark at the end of this of my title is what CHERISH is trying to address. It's trying to understand the impacts of predicted climate change to our coastal sites, and hopefully as we go through over the next 35 minutes or so, be able to show the work that CHERISH is doing to try and address that, and to try and remove the question mark from the end of the title. Because once we have information on what's occurring, it means that we are able to make better decisions about the management of coastal sites, of people living around the coast, how we can adapt and mitigate the impacts of climate change. So what are the main impacts of climate change? We're an island nation. We're on the northwest of Europe. Probably the biggest impacts of climate change do occur along Irish coastlines, and we're already to a large extent experiencing some of those. The image at the top left there is Hurricane Lorenzo, as it was. Look, he was downgraded just before it hit Ireland there a couple of years ago, but this is the only, well, category 5, the most northerly and the most easterly in the Atlantic Ocean that we'd seen previously. And with predicted climate change, we expect to see these high magnitude storm events perhaps more frequently, and certainly with a change in the pattern of what we're used to. And we're also expecting that the say like the wind velocities or the rainfall associated will be greater than what we've experienced more. And they combine with other factors such as storm surge, pushing the water up against the side, increased wave action closer to shore, the rainfall coming in from inland areas to create impacts like coastal flooding, and to change erosion patterns around the Irish coastline, which will obviously have an impact to the cultural heritage, which CHERISH is interested in, but also to communities living alongside coastal areas. And the two schematics at the bottom sum up the impacts that CHERISH is trying to look at, to understand more, and hopefully to address. And it really comes down to a change in water level, that the sea level is at a certain level currently. If we have melting of ice caps, particularly Greenland and Antarctica, that will lead to a rising of the water level. If you combine that rise of water level with increased changes to storms, you've got your storm surges, which can push water further up, and you have the waves. All of those combine to result in the water from the sea having a greater impact to our infrastructure and our sites on the land. So we will see increased flooding in particular, and we would see increased erosion happening. And they're really the main impacts of predicted climate change. CHERISH is then trying to look at a number of sites both around Ireland and Wales to greater understand, one, what is going on in these areas, and two, what we can do about those increased sea levels, increased storm surges, changes in wave parameters. And we divided our resources in Ireland into about 5 sites. We're looking in Dublin, Wexford, Waterford along the Copper Coast, and in Kerry. And within those 5 main areas, we also have a number of individual sites. These would be promontory forts, shipwrecks, and more recent archaeological buildings in there, which we are then monitoring with a range of techniques to establish baseline data from which we can understand change and understand the impact. We're also doing this in Wales because it's a Ireland-Wales funded programme, and our Welsh colleagues have identified about 13 different areas, and again, sites within those 13 different areas. Over in Wales, the project is led by the Royal Commission on the Ancient Historical Monuments of Wales in partnership with Aberystwyth University. And in Ireland, there's ourselves and the Geological Survey, and there's the Discovery Programme, Centre for Innovation and Archaeology. And CHERISH is about combining the expertise of those 4 partner organisations and to allow cross-border travel when it was possible, and hopefully when it will reopen again, to enable the skills that each partner has to be able to transfer that to our partners and apply them in the different settings. So we in the Geological Survey have gone over to Wales. Our Welsh partners have come over to Ireland to look at these sites and to try and understand them. How do we look at these sites? We use what we term the CHERISH toolkit approach. It's summarizing this infographic over there. A number of different techniques which we apply in tandem, because the important thing to always sort of like understand and remember about coastal sites is they are impacted from both the land and the sea. And so to understand the processes that are occurring at these sites, we want to be able to have a suite of techniques where we are able to understand what is going on from both the marine side and the terrestrial side. And I'll quickly just bring you through some of the techniques. I'll be focusing today on some more than others. We'll have a quick overview here. Starting in the offshore area, there's a diver down there, number 12. Survey wrecks, there are 3 in Ireland that we're looking at. There are a number in Wales. We also use the vessels from the Geological Survey to have multi-beam surveys, which is to get the shape of the seabed, including whatever is on there as well. We use terrestrial laser scanners. This is the image number 9 there to record perhaps vertical cliff faces and get very accurate measurements on what that surface looks like. On shore then, we use stuff like geophysics. I got a few images of that from our archaeological colleagues to understand perhaps some of the buried archaeology. We use GPS to measure the archaeology that we can see. We have cores that we're able to take to look at what the long-term environmental changes in sites. And then up in the air, we use a lot of drones to map areas on, say, like a kilometer scale. We use LiDAR from planes. We've been hoping to get Dublin Bay the last couple of months. The weather hasn't been kind, so in the next week is our last opportunity with tides. We hope to get a good LiDAR survey done there. We take aerial photographs, and we even use satellites as well and satellite images. So different partners will focus on different techniques. We will try to go to sites in tandem, and then each of us will use our own expertise and learn from the expertise of the others to build up this holistic view of what a site is like now. And if we're able to return to sites over the lifetime of the project to understand the change that's going on in that intervening period. When we go out and we collect data, we can collect it on a range of scales using sort of satellites, using LiDAR, using our drones. We can get a kilometer scale using our drones. It's generally about a 12-kilometer stretch of coastline is probably about the maximum that we've surveyed. But it can come right down to the image on the bottom right, where we use one of our laser scanners to record just one eroding vertical cliff and have that in very, very high density to create a three-dimensional model of what the surface looks like. In Kerry, we've applied it. This is balanced scale aids, and it is a three-dimensional elevation model of the bay that we're then going to look to link in with some of our other data to understand then along this coastline what is occurring to some of the individual sites of interest. We take our terrestrial data, and we then also want to complement it with the marine data. And from the Geological Survey, this is one of the expertise that we bring to the project from the National Seabed Mapping Programme, the Infomar programme, where there are a number of vessels currently in Cork measuring the sea floor. And we get information of what that sea floor looks like. This is examples of the coast in Wales. The image in the bottom is of Sarn Patrick. That is a glacial esker that is coming offshore that would have been formed under the ice about 20,000 years ago. We've been able to map that. The grayer images is another kind of information we're able to get, which is the strength of reflection off the ground, and it tells the difference between hard substrate and soft substrate. And in the two images up the top, the darker black images are of a high reflectance, so this is gravel or rock will give you that. The grayer ones give you more soft sediments like soft sand or mud. So we're able to build up a picture of what the offshore looks like and start to maybe infer what it's made of. And this year in particular, we're looking to go out to some of our Welsh sites and to actually put down a sampler, take the seabed, a small sample of the seabed, and see what it is. Is it gravel? Is it sand? To then build up sedimentary maps of that region, which then helps to maybe inform what kind of processes are occurring just offshore, which will then impact the onshore. And the two images on the right there are of wrecks, and I have a few examples of wrecks later on in this talk. Specific to Waterford, and I've included a number of sites in here and later in the talk. We are looking at a number of promontory forts. There's a rich collection of promontory forts right along the Waterford coastline, and in particular in the Copper Coast. And CHERISH is looking at a number of these, and I've just highlighted three here where the team has gone down and done some more in-depth surveys. So that would be our colleagues in the Discovery Programme. And so we'll look at some of the results that have come from these sites. What do we do with the data? Our primary kind of like data acquisition or technique for collecting data is using drones or other techniques to build elevation models. So these are three-dimensional representations of what the land looks now when you survey it. These are important for a number of reasons. You can use them to assess the impacts of flooding. In there, the low areas will be more likely to flood than others. And once you create a three-dimensional model of an area, you can start saying, okay, well, what happens now? What happens if we raise sea levels by ½ meter? What kind of impact that will have? What areas become flooded? So you get to understand from these elevation models, maybe vulnerable areas that will be more prone to the impacts of climate change. The other critical thing about these elevation models is they are a snapshot in time of what the coastline looks now. And when you have that, so such as these ones in Dublin collected in 2019, you're able to use that as your baseline from which to look at any change that happens. So a number of our sites we visited in perhaps 2018, we've returned in 2019, go again in 2020. They got a little bit delayed because of COVID, and again in 2021. And from that, you can start to then build up a record of the change that's occurring now, which helps inform what will happen in the future. It's not possible in all sites, but that's certainly what we are working towards. And I have a few examples of that to show show people. We can also take that elevation data and we can combine it with other sources of information. So we can take the geological maps from the area, and we can start maybe bringing in other factors like what is the underlying rock type, what's the underlying sediment type, will it be prone to erosion or not, where is it going to be weaker than others, and we can take that information and then we can then perhaps use that to inform what we're seeing now. So it's all about building up information and knowledge about the sites that we're looking at. We can also integrate different technologies, and this is one of the things that CHERISH has been focusing on, is not just use one technique in one area, but combine different techniques to get more information out. And the examples here from Dublin, the image on the left is a point cloud of an eroding bay in North Dublin. There's a 16th century harbour in there that CHERISH is looking at. And using our UAV, we're able to get a point cloud. So that's a point, lots of points, that covers a large area, kilometre scale area, and we'll have 1 point, 1,000 points every metre in that area. And each of those points will have a geographic coordinate, so an X, Y, so where is it? But critically, it has a Z component, so that's its elevation. So it means all of these points together builds up this three-dimensional model of what the surface looks like. With our UAV, we get 1,000 points per square metre. Using our scanning total station, a laser scanner, we can get upwards of 160,000 points per metre squared. So your points are much closer together. You're getting much more information. But tied to that, it's also takes much longer to get that information. So it's about using the relevant technique to get information from an area, and the UAV will be very good at getting kind of large areas, certainly very flat areas. We'd use our terrestrial laser scanner to look at the eroding cliff face itself, so to target in on maybe a vertical section that the UAV isn't so good at and get very precise information from that area. This image again is just showing that incorporation of your point clouds from different sources, UAV and scanning total station. And so we've applied this technique in a number of different areas, in Kilmichael Point in Wexford, where the nearby beach is eroding by about 6 meters per year. There's a massive amount of erosion going on in there. We've applied it in Dublin, in Dalkey Island, and we have a number of sort of virtual field trips up on our Sketchfab account. If you just Google Geological Survey Ireland Sketchfab, you should be able to come up with some of the areas that we have surveyed, and our work on our Copper Coast is going to go up there too. We're also looking at integrating the technology from the marine side and the terrestrial side, and the example that I'm showing here now is Puffin Island over in Wales, where our colleagues in the Royal Commission got a LiDAR survey of the island. The Geological Survey then went out there, and with our boats, we surveyed the marine side, and then we stitched those two data sets together. And that's what's shown there. It's one of these seamless onshore-offshore maps. These are extremely important for understanding the processes that are going on there, because with our bathymetry, that's the sea floor, that's the shape of the sea floor, we're able to use that to generate wave models of, what will storms do in certain circumstances, and that informs then what's going to happen on the onshore side, which is where we have the LiDAR data. So if you're just looking at the marine bathymetry, it tells you one story. If you're looking at your terrestrial LiDAR, it tells you the onshore story. We're stitching those together to get the seamless map, and it's very difficult to get data from the shallow marine areas, and it's one of the benefits of CHERISH is it's allowed us to really target those areas in both Ireland and Wales to get that information from very shallow intertidal areas that allows the data sets to be stitched together, and for us to then understand more maybe the hydrodynamic processes that are occurring offshore of these sites, which would then be impacting the onshore terrestrial story. we're also then taking that kind of information and we're linking it in with the archaeological story. And the images here from a big hill fort over in Wales, one of CHERISH's key sites, Dinas Dintley. And our colleagues over there have done geophysical surveys, which have then identified unknown hut sites within these areas that are experiencing high amounts of erosion. And CHERISH is about trying to understand and capture what's there now, to understand the change that's going to be occurring to these ones, and for a number of our sites to generate management plans for the owners or custodians of those sites to best manage these going forward. So now we become a bit more local. So looking at a section of the Copper Coast, we are looking to build the model of what the coastline looks like now. Shown in front of you here is the three-dimensional model of, it's about kind of 4 or 5 kilometers of the Copper Coast around Bunmahan. We are looking at a number of promontory forts along the stretch of coastline, and over the next year or so, we're looking to extend this this model either side to have a larger picture of what the coastline looks like now, to then look at future change. And bringing here the work of my archaeological colleagues, looking at some of these sites. This is Dunabratton. It is the largest promontory fort in the Copper Coast. It has an embankment on the northern side. We have here a number of images from the area. This image in the bottom left then is of a UAV survey of the area, and we see an embankment here that's picked up from the elevation data, and the promontory fort then is to the south. What's also interesting about this site is there's actually a small little subsidiary promontory fort off to the west as well. So there's actually 2 in 1 in this area. And this site's been studied before, going back to the over 100 years ago. It was looked at, and a number of archaeological features were identified. There were some huts up near the embankment. There was the subsidiary fort, and there was a number of enclosures found. And my colleagues have gone over and have done a new geophysical area of geophysical study of the area, and that's there in the bottom of that picture. And looking at this geophysical one, and this is what the archaeologists tell me as well in there, some of the features come through, and I think you do need an archaeological eye to see some of these, but there are a number of additional circular features which have been identified in this area and are shown on the image on the right. And these were unknown prior to the CHERISH site going, the CHERISH project going in there. And they appear to be a number of additional enclosures and possible hut sites, and an additional ditch that was there, which is building up our understanding of this promontory fort, which is occupied from about the Iron Age through to the medieval period. And the story that appears to be coming back to us with these additional enclosures is that there's a succession of habitation in this area, and that there were a number of different phases of occupation, and that some of these enclosures were built on others, and that there was a very, very long history of occupation at this particular site. Looking at another one, this is Woodstown. It was surveyed in 2017 and in 2018 by a series of walkovers. There is again an embankment area with a couple of banks and a ditch running through. There is ongoing erosion that's occurring in the sites. You can see in the image on the bottom left there, active erosion, which is occurring, having a steep-sided cliff and lack of vegetation. This site is interesting because there's a good possibility that the existing promontory fort and the offshore islands were at one stage maybe joined, and that then over history, then due to the faulting and the erosion, then that bridge has then sort of like been lost, and now you have the isolated islands. Using the UAV survey, identified a possible hut site on one of the islands. We can see in the bottom right the embankment for the area, and in this site here, that there's additional archaeology. There's a lime kiln on a nearby beach. So again, CHERISH is recording what's there currently, establishing the baseline data, and if and when we get to return, or people in the future get to return, to then look at that change to understand the change. The final example I'm going to show from Waterford is promontory forts around Ballynard. Here, in a very, very small area, in a couple of townlands, there is 6 promontory forts in the area associated with the O'Bricks, which had control of this area for a really long period of time. Also in this area, lots of the mining, as Robbie was mentioning, across all the Copper Coast, but due to the geology, can be a higher density in some of the areas. And again, this site occupied from the Iron Age through to the early medieval, and then beyond with more modern inhabitants. The image at the bottom left here is from a mining adit in the area from inside looking out. There's a lot of these adits in the region. The image at the top right is a photograph of Illinois brick in the area, and again one of the 6 promontory forts in the area. And the main central image, then the elevation model of this larger area, with and I think it's Rinamo is the name of this headland here, and 2 promontory forts off the end of it, and additional promontory fort here on Illinois brick. So a very, very high density of forts, indicative of a dense population through time. CHERISH is then looking at these sites, trying to identify the existing archaeology, but also anything new in the area. And so these are from the UAV data that we would have collected, a 3-dimensional model, which was then able to identify features, the modern kind of castle field, some of the embankments then on either side of the promontory fort. And the image on the right then is of Ilano brick itself, and number of different archaeological features in there, hut sites on the island, the embankment in the area, perhaps indication that this was a larger feature which has then experienced erosion through the ages. So some interesting signs in Ballynard. Again, a geophysical survey was done of this area. This is off Rinamo in the bottom left, and the area sweeping around Ilona brick is kind of like hasn't been surveyed just to the logistical difficulties of getting out there. But using the geophysics to look at some of the subsurface, we can see a number of field boundaries, these kind of like linear features that are shown through the data. I hope you're able to see my mouse as I move it along. So these are existing features that were there, not observed on the actual surface itself, but retained in the subsurface, which the geophysics is able to pick up. Able to pick up a lot of these mottled areas here, which is likely waste from the mining that was done in the area, to produce this mottled feature, and also some new features as well, some linear features that could be associated with the mining in the area, again that CHERISH has picked up in some of the areas. So while these sites have a history of being studied, there's always advances to technology which allows you to perhaps see some additional features. So those sites are some of the work that we've been doing in the area, and particularly the archaeological side. And for the final part of this talk, then I want to look about the change element of it, because a very important part of what CHERISH is doing is establishing this baseline data, establishing the elevation baseline, establishing the archaeological baseline. But really what we're interested in, what we want to be moving towards, is our understanding of change, of what's going to happen to these sites. And if we can understand what's going to happen to these sites, we can perhaps plan on what we're going to do to these sites. Are we going to do, just record them digitally? Are we going to do invasive archaeological digs to then get the artifacts to preserve them for posterity? Are we going to actually move these sites? Discussions are around that. Do you actually relocate these sites further inland, so at least the sense of what was there, if not maybe the authenticity of it, is preserved and remains for future generations? And even though CHERISH has been going since 2017, at this stage 4 years, it's not a long time in terms of geological time. It's not even a long time in terms of understanding climate change, but it is still ample time to observe change that's happening. And the first example I want to show is from Dunbeg Fort in County Kerry. This was surveyed in 2017 with one of our UAVs, and we had a model produced of it, returned less than a year later, and a very large slippage had occurred, which removed a lot of the embankment. And not only is that tied down to a 1 year interval, we can quite accurately tie that into one of the storms that was there. I think maybe it was Storm Eleanor that happened, which almost overnight this happened. And by using the understanding and techniques of the Discovery Program, who surveyed this area, linking that with the geological knowledge of the survey, we're able to sort of combine and talk about the mechanisms of change. And in this instance here, it wasn't anything from the coast that caused this erosion. It was actually the high rainfall that was inland that was coming down, and it was likely that created a line of weakness in the rock, and a whole section about 30,000 meters cubed just slipped overnight, and we lost that. So in terms of looking at a site like this, it's not necessarily coastal defense that could have prevented this happening. It could have been diversion of waterways just further inland, so that the water wasn't coming down in the great quantities. And that's really what CHERISH is trying to move to. And we can look at things kind of qualitatively by just looking, let's say, change has happened and try and describe what has happened. But we want to start moving to quantitative change, to start putting numbers on what's happening, because that can help decision makers to justify actions if you're able to really try and nail down the kind of change is happening. And for the last part, I'll briefly show some of the examples of how we do that. The first one is by looking at historical maps, and you're able to then map maybe coastlines and how they recede. And this can be very powerful in areas where you have high erosion rates, and you can have hundreds of meters that are lost since the first ordnance survey maps were produced. And so you're able to look at long-term change. But we're also able to look at short-term change and what's happening. And so in Waterford along the Copper Coast, we surveyed it in 2017. We returned there recently, and we surveyed a section to the east of Bunman, and we're able to look at the two data sets. And that's what is showing now. And they each tell their own story of what the coastline looked like at the time that they were surveyed. But by creating what's called a DSM, a digital surface model of difference, by subtracting one from the other, we're able to look at the change that's happened between those 2 years. So in this case, 2017 and 2021. So what's happened in that 4 year period. And the color coded for some of these images I'm going to show you now. Red means that erosion has happened, or the land level has dropped. Blue means that it's raised up, so deposition in a geological process that's happening, and this is on the order of about like 2 kilometers or so. It's quite rough at the moment. The sea is in there as well, so that impacts a lot of the color here in the bottom of the image. But from this, we see that change is happening. There's a lot of red around the coastline here, so it looks like there is ongoing erosion at that coastline. And what we hope to start doing is put numbers on that to see what is occurring over that 4-year period. We can use this and we can look at individual areas, zoom right down. This is on the beach of Bunmahan. This is the sand spit on the eastern side. Red is erosion, blue is deposition. So you can see that there's a bit of maybe of a complex occurrence happening, or has happened in the 2 snapshots 4 years apart. And again, this is further along the coast, and there's still, this is very rough data, that there's some things I still want to do to ease it, but it gives an indication of the type of change that's happening. We're able to apply this technique, and we have it in other areas. This is Wexford, where we have one of our longest time series of surveys from 2017 through to 2019. And again, the colors in the 3 images below, sorry, I was using the mouse on the wrong screen there. Red is erosion, blue is deposition. And so D is the difference between 2017 and 2018, E is 2018 and 2019, and F is the whole thing, 2017 to 2019. And the important sort of like take-home message from these images are, 1, that change is happening, but 2, it's not uniform change. It's not the same every single year happens. From 2017 to 2018, we see that there's a small bit of change, that there's a bit of erosion around here, but the big thing happens 2018 to 2019. What also happens is that the focus of erosion seems to shift northwards. So we can start to build up patterns of what is happening. And the more we can survey, the more we're able to tell, what is going on between those surveys. So if you only survey once every 10 years, you get one picture. If you're able to return every single year, you get a very different story. If you can return every single month, you probably get a different story. And that's what the stage that we're at is really just trying to understand the timescales and the short timescales that these are occurring on. We're able to take that technique and we're able to apply it to shipwrecks. And this is the Manchester Merchant in Dingle. Sank, I think it was about 1900, I think it was about 1906. Tried to look at my notes, but Zoom was covering it there. But the shipwreck was surveyed in 2009. It surveyed in 2009. CHERISH returned in 2019. So we have a 10-year difference that happened. And again, the image at the bottom, red is erosion, blue is deposition. And so we start to see change happening. We see erosion down at the bow of the vessel, which is at the southwest side. We see maybe deposition up in the northeast of it. And then the superstructure itself is beginning to break down. We can start to look at that. And what's interesting here, we got some environmental data. We gave an organization, the bathymetry, they ran wave models to understand maybe the heights of waves, the direction that they're coming in, to start tying in the data that we're collecting with the environment in which these sites are in, to then understand maybe what is causing the change. And in this area, you're getting very, very large waves, about 1.75, coming up through Dingle Bay and then impacting it. So it's probably largely impacting that southwest and eroding that southwest and depositing into the southeast. And so if we in the future see higher waves and we see more storms, then we perhaps will start to see more of this happening, and there'll be faster degradation of the sites. An example again, City of London down in Wexford, we have more story going on, surveyed in 2015, 18, 20, and actually it was surveyed just last week again, so we're going to have a new picture happening. Top left of this image is that difference. Blue is deposition, red is erosion. So between 2015 and 2018, we've got a lot of sediment came into the area, but between 2018 and 2020, a lot of erosion happened. So again, this idea of maybe episodic change, of differences occurring, and different processes that are occurring, that are happening on small scales of 1 to 2 years. We see great differences, and maybe these are even tied just to our one-off events, our storm events that are occurring. And these are questions that we still don't know. But in this one here, if we look at the long-term change from 2015 through to 2020, or the medium term, I should say, it's of ongoing erosion that's happening, and ongoing erosion and ongoing degradation, tied into the environmental parameters of wind and wave, or wind from everywhere, waves predominantly from the south coming up. Finishing up here, almost done. So just a final slide almost here to show some of the other techniques. This is using satellite images, and it's using the penetration of light through water to try and see, are we able to extract information on what the seabed looks like using satellite images. The advantage of this being that satellite images cover the globe, they cover all the coastline of Ireland. Is it a way of getting information about our coastline? Because CHERISH is very much about focusing on individual sites, maybe looking at the region either side, a few kilometers either side. Ultimately, we want to be moving towards tens of kilometers, the whole of the Irish coastline, what it looks like now, what's happening to it, how is it changing, why is it changing, what can we do about it? And so to finish up, last slide, some of the legacy of CHERISH. All of our data is freely accessible. It will be released through the partners like the Geological Survey. There's an open topographic viewer that the GSI has. A lot of our data will be there. We're generating new knowledge about heritage sites, particularly at-risk ones, and we're involved in coastal communities. Like, it was great to the partnership that we're cementing with the Copper Coast Geopark, working with people that live in these areas, so our data doesn't just sit on servers unknown to people, that it's freely available, it's their resource, people can do with it what they like. And so with that, I'll say thank you very much.
Absolutely fantastic. That's really, really fascinating, Kieran. Thanks very much, and Robbie as well. I'm blown over by the detail and the sophistication of the maps. It's absolutely, it's like it's looking at, you're looking at the 21st century at its best. I'd imagine the information that you're gathering, the different types of information, the different maps. It's utterly fascinating. Thanks very much, Kieran. So guys, I'm going to kind of open it up a bit and see if anybody's got any questions out there that they want to ask you. Feel free to pop them in the chat. I've got one from Kaylee's, the first one. So tell us from both of your perspectives, what's the biggest challenge facing coastal areas because of erosion?
Yeah, I'm happy to kick that one off, Robbie, if that's all right. Biggest challenge, loss of land. That's what it comes down to. That's what coastal erosion is happening. And what we're noticing now is because of the increased frequency of storms that have been recorded, and because of the higher magnitudes of events, the processes that have been recorded around the coast, and there's erosion in some areas, there's accretion in others. Stuff that gets eroded has to go somewhere. You lose a cliff face, and that becomes sediment that gets moved, and it moves somewhere else. And so that's why we can see in some areas beaches grow and they can grow. What happens though is when you change the environmental regime, is the currents in the area can change. So rather than your material maybe being shifted to a beach on the east, maybe that material is being shifted offshore, and then that will sit offshore. And so effectively, we haven't lost that material, but we've lost it from the terrestrial area, and so you then lose land as a result of that. And that obviously has big implications. You can start from agricultural land, farmers who are losing fields. And we've spoken to a number of farmers, that particularly down in Wexford experience the high winds, who will say that when they were kids, there was 3-4 further fields across the way. They're all gone. So you're losing agricultural land, using the ability to have sheep or grow crops. You take that and then you look at areas where there's a higher density of people, and then once you have infrastructure there, that there's been a cost that has gone into building that infrastructure, and then you start to lose that infrastructure. So that's then where really the costs and where the impact of climate change really start to be felt. And because we're an island nation, most of our cities are along the coast, so we were seafarers back in the day, so we have a lot of infrastructure on the coast, and you can try and build to protect areas, but one, it's very expensive, and two, many of the lessons that are being learned is it doesn't last. There are examples in Wexford that, you know, they spent several million in coastal defence to try and protect areas. A storm comes through and it's gone. It could be almost overnight that it's gone. And so that's when the really tough decisions have to start being made about what do you do to your important areas that are impacted by erosion, and that's where the big challenge is.
Sure, sure. And just can I say something? And this is one. I live in Wexford, and we're quite familiar with what you'd call the shifting sands. I mean, the place is called after it. But the idea of deposition, and as well that causes another challenge. We have towns in Wexford that used to be coastal towns that are now several miles inland. You know, that they were ports and now they're not anymore because the rivers have silted up. The things have changed. So as you say, that the stuff has to end up somewhere. So yeah, that's fascinating. I have a question from Mary O'Riordan here. Kieran, she says, thank you for your fascinating talk. Would you say that there are now enormous challenges facing Irish coastal communities going forward, and are there any easy solutions? I think I probably know the answer to that one, but please do, Kieran.
So yeah, you just answered with yes and no. I think are the two answers for that one. Look, that there is, you know, not all coastlines are the same. So that's the important thing to remember. And you know, the other thing to remember is, like, change has always happened. Change in coastlines, you know, it's always been changing. What we do have to be aware of is maybe the rate of change that has occurred. But you know, there are natural cycles that go through. You can get through a period of you know, long-term erosion in one area. There's then change to long-term deposition, which then changes. I guess the key thing about what's happening now is, like, the unknown factor about it. Like, do we shift the regimes from these natural long-term processes to something that we haven't experienced before? And that's where the big challenges come in. And the other side of it is, you know, that with higher investment in coastal areas, what we stand to lose now is greater than what it could have been beforehand. So that areas which was agricultural land are now towns and villages, or the suburbs of towns and villages, and so they are now kind of like impacts more people and costs more. And really, like, I don't want to cop out on this one, but know that there isn't easy solutions for them. There are really only hard decisions. Now, that's the areas that are changing. You have other areas, you know, if you're in a hard rock area, if you're high up, then this kind of change doesn't necessarily happen. Like the area where we're seeing most change is the soft sediment areas, and so a lot of Wexford, it's composed of glacial material that was formed 20,000 years ago. It's not hard rock area, it's sands and muds and stuff there that extended out into the sea that was there. That material is very easily eroded because there's nothing that, you know, holding it. There's no bedrock holding it together. If you move somewhere on the west coast, kind of like Achill Island, these areas, they're being battered by the Atlantic for years. You know, that there's almost no sediment in those areas, so they're still experiencing change, but perhaps, you know, it's different to it. So really, for coastal communities, it's about what understanding the processes that's going on in that area, and what are the solutions that benefit that community. It's not a one size fits all.
Sure, I mean, we're finding that across all of our talks, that, you know, and the other idea is that everything is connected. I mean, you spoke about what's happening on land and how that can affect what goes on at the coast. I have a question from Owen. Does the collapse of land in the sea cause damage to the underwater ecosystem?
I'd have to rephrase that and say, does the collapse of land cause change or impact the underwater ecosystem? Because what are we to say what's damage and what's not? And in a lot of areas, you know, ecosystems can evolve around change, and they need change that happens for it. So, I mean, one, very definitely, yes, collapse of land into the sea will impact the underwater ecosystem, that they can be increased siltation, but it can also then provide new areas for organisms to grow on. It can alter what's there, and so equally, does it improve that ecosystem? I mean, what we have to remember is these are coastal sites, that they're coastal sites which have historically experienced change is going on. So probably for the ecosystem, this is to a large extent normal behavior. It's just the rate of change that will happen. And again, that could be site specific, but
Sure.
it certainly changes what's there.
Sure. And that leads me nicely into the next question, which is, I'm going to roll two into one. Is erosion happening at a faster rate now? And is the impact different between Ireland and Wales? So faster, and is there difference?
Faster and difference. Okay, faster. I would have to say that, I can't answer that based on what we've done. Change happens over long periods, and when geologists look at change, like our baseline is 4.56 billion years old. It's long periods of change. Anecdotally, speaking to farmers, speaking to people in the area who've grown up with this, almost across the board, when we're in areas and we're chatting to people, they say, oh yeah, it's been going. But the last 20 years has seen massive change, and that's particularly down in Wexford. The time scale that CHERISH has been working on, so 2017 onwards, it's really too short a time to look at long-term trends. There's always natural variability that goes on, and to understand and to stay, is stuff happening faster? To give a scientific answer to basically not answer the question, is you need to look at longer time periods, and you got to look at what's going on. You got to compare that to the baseline, and unfortunately, CHERISH, the work that we've been doing, isn't in a position to answer those kind of questions. What we hope to do, and what we are doing, is creating that baseline now, so people can understand, and we're able to compare the change maybe that's happened now with a series of the aerial photographs that were done. I think it was 2005. Some were done in the 60s. So we're able to get some snapshots, but overall, no. All we can say is that change is happening, and from a lot of scientific reports that have been done, they'd say in areas that the change has been faster. The other part of the question is there a difference? It's difficult to generalize. I think that the answer is yes. It does differ, but it differs within Ireland. The erosion that's happening in Dublin is different to what's happening in Kerry. It's predominantly down to the type of geology that's there. And it's down to how that is exposed to the environment. So is it exposed to large areas of the Atlantic? It's the main part. What I will say, which was surprising for me, and I think is a new bit, from the CHERISH project, is the type of erosion that we're seeing is episodic, and we're seeing that this is similar in both. Right. In both countries, is it happens to be associated with these high magnitude events. And what we're also seeing a lot of is that the erosion isn't happening from the base. It's not necessarily the waves. It's happening within layers of either the rock or the sediments, and it's water that is then coming preferentially along certain areas, be it the rock soil interface, or if you've got clay layers against sandy layers, the water is focused along those areas. And in many ways, it's reducing friction, and that's what's actually causing a lot of the erosion. That the waves are creating a steep face, but the actual erosion that we're seeing is coming from the land coming in, and that's similar in both jurisdictions, in places like Dunbeg and Dinnistintley, certainly.
Mm-hmm. Listen, that's fantastic. Thanks very much, Kieran. Thanks very much, Robbie. I'm going to sort of wrap up now, or at least move along a little bit, and tell you something about our competitions, unless we have any more questions coming in. I think we're okay there for a minute. So we ran a competition today, it being Fascination for Plants Day. So I'm just going to pop up some of our short list of of winners. If you'll bear with me, this is the fun bit of this. Now, hopefully you can see it. So today we had as a prize, we have a family pass for the Copper Coast Visitor Centre. So we'll be going to see exactly what we've been talking about today. As I say, yesterday was the Fascination for Plants Day. So we've asked people to send us in their plant pictures, and I'm gonna show you our short list. Mike Kinselas is our lovely creeping plant on our old shed. It's a lovely colour this time of year when it's in flower. Marika Burke has sent us a beautiful image of a really delicate blue flower called Speedwell, not one I'm familiar with. There's Cara Foran from Clare has sent us beautiful buttercups, helping our pollinators. And we hope you're all taking part in No Mow May. Leave your lawnmowers behind for this month and give our little friends a chance to pollinate our flowers. Next one up, there's Sinead Cashin from New Ross with a wonderful splash of yellow color. I always think of May being a yellow kind of a month. It's very prevalent, certainly in this part of the world. There's Lydia McGovern, who sent us from Waterford, sent us clover, and she says possibly wild broom on the Tremor Nature Park. Memories of childhood, wandering the fields around the housing estate. So our winner, I'm happy to say, is, whoops, sorry, I missed one. There's one from, whoops, where's it gone now? And our winner, Mike Kinsella. We love this shot. It's a great shed. It's great color. So Mike, the passes are on their way to you as we speak. Now, today's theme, of course, as we've had the guys on from the Copper Coast and the CHERISH project, is to be coastal. So you can enter by sending us stuff on email, calmas@wit, tweet your pictures at calmaswit or Instagram. On Facebook, we're Bealtaine Biodiversity. Tell us something about the picture. The location would be great, and tell us your name. And the prize is to be family pass to the Copper Coast Visitor Centre. So we're delighted to have that. I'm gonna ask Kaylee to come on and tell us what's going on in the rest of the. And I should tell you that Kaylee Foran is probably the hardest working science communicator in the country this week. She's been on radios, Pints of Science. She's just doesn't seem to stop. So Kaylee, tell us if you would. What have we got to look forward to?
Thanks very much, Ben. Flattery, should I say, will get you absolutely everywhere. So thanks very much for that. So we have had a jam-packed couple of days, as you guys all know. But over the next couple of days, this actually is just our themes for the competition for the next couple of days. So today's theme is our coast. Tomorrow's theme for the competition is going to be pollinators. Friday's theme is going to be rivers and waterways, and then Saturday's theme is going to be biodiversity all around us. So if you just pop on to the next slide, it looks at what we have done over the last couple of days with our festival. If you've missed any of these fantastic events, absolutely not to worry. They are all available on our Bealtaine Living Earth site. So it's www.livingearth.ie, and all you have to do is go to our playback section. On our playback section, you have all the events just in front of you here. So we kicked off our festival with the Lafcadio Ahern Gardens in Tremor. We heard from Mark Rowe looking at wellness in nature. We had a fabulous talk from Eric Dempsey from Birdwatch Ireland, talking about all the beautiful garden and migratory birds. And then yesterday, we had the guides from JFK Arboretum. Of course, today we had the Copper Coast. And then moving on to tomorrow and the next couple of days. Tomorrow is the World Bee Day. So we have a very special guest. We're going to be joined by Una Fitzpatrick, who was the founder of the All Ireland Pollinator Plan. So you may have seen in your local communities, in your green spaces, there's these signs that are basically outlining why this particular patch of grass isn't being mowed. And the reason behind that is to give our pollinators and our insects a bit of a chance and to just promote more biodiversity in our area. On Friday, we're going to hear from local man from Carrick-on-Shore, Brian Wright. He's going to talk to us about the Carrick-on-Shore Blueway, and that talk is entitled The Head of the Tide. And then on Saturday, we're going to be really looking at what we can do to promote biodiversity in our community. We're going to be hearing from Yvonne Grace, which is a horticulture lecturer in WIT. So we have an absolutely fantastic schedule of events. Don't worry as well, we have loads of things for you guys to do after the festival is finished. We have a really big and comprehensive range of guides and resources, which are also available on our website. They're just the green buttons along the top. Some of the guides were also developed by the Copper Coast, which you heard from here today. So as well as that, if you have any little people in your life, we also have a couple of guides and short video clips from the likes of the Seal Rescue Ireland, which students from all around the Southeast are going to hear from tomorrow. And we also have a range of kind of small online workshops, which were developed by the About Wildlife explorers in the aquarium in Galway. So if you have any little people in your life, they can get in on the fun too. So thank you very much, Ben, and I'll leave it back over to you.
Super. So yeah, lots to do, lots to see and do. We're really looking forward to the rest of the festival. I'm gonna wrap up because we have run a little over time, but I just want to thank Kieran, Craven very much for a really fascinating talk, and to Robbie Galvin as well from the Copper Coast. Guys, it's fascinating. It's wonderful to have you on, and I want to thank everybody who came on with us, and all our viewers out on the website on the live stream. So for today's Living Earth TV, it's thank you very much from me and
fascinating stuff, guys. Fascinating
team.
Fascinating.
Thank you. Thanks, Paul. And we hope to see you again tomorrow and for the rest of the week. So thanks very much.